కాకపోతే ప్రెజెంటేషన్ వాయిస్ వినిపిస్తుంది, ఇబ్బంది లేదు.
నో ప్రాబ్లం సార్.
చేద్దాం సార్ అట్లయితే.
సార్ కరుణాకర్ సార్, ప్లీజ్ స్టార్ట్ ద ప్రోగ్రామ్ సార్.
A very warm welcome and good evening to all the participants on the occasion of 105th birthday anniversary celebrations of a great mathematician, Dr. Komaruguli Chandrasekharan Garu, and the 71st birthday anniversary celebrations of our former head of the department, Dr. Nagal Prabhakar Rao Garu. The Department of Mathematics is organizing a one-week international faculty development program on innovative applications of mathematics in association with
role in shaping and advancing various fields, underscoring their importance as fundamental tools in science and technology. Mathematics and statistics find applications in a wide range of fields, demonstrating their significance in various aspects of our lives. They provide the necessary foundation for advancements in many fields. Thus, any field is directly or indirectly linked with mathematics and statistics with their applications. Hence, they equip us with the ability to analyze and solve the problems. Both mathematics and statistics mainly teach us how to approach challenges logically for the purpose of overcoming hurdles with the suitable and appropriate solutions. Today, we have a wonderful resource person with us. The resource person for today's section is Dr. G. Srinivas Rao Garu, Professor, Department of Mathematics and Statistics, University of Dodoma, Tanzania. Dr. G. Srinivas Rao Garu is not only a professor, but also a source of inspiration, guidance, and valuable support to the student community. In the vast ocean of academia, there are certain individuals like Dr. G. Srinivas Rao Garu who stand out as beacons of knowledge and wisdom. On behalf of Department of Mathematics, I express my gratitude to today's esteemed resource person, Dr. G. Srinivas Rao sir, for graciously accepting our request to deliver his valuable lecture in our International Faculty Development Program. So thank you, one and all.
Thank you very much, sir, for your valuable message. Today is the third day of the one-week International Faculty Development Program. Today's speaker is Dr. G. Srinivas Rao Garu, Professor, Department of Mathematics and Statistics, University of Dodoma, Tanzania. Now I request one of our staff organizer, Ms. K. Sunita, to present profound profile of Dr. D. Srinivas Rao Garu.
Good evening all. Welcome you all to a one-week International Faculty Development Program on Innovative Applications of Mathematics. I am honored to introduce today's resource person, Dr. Gadde Srinivas Rao Garu. Dr. Gadde Srinivas Rao sir is presently working as a Professor of Statistics at the Department of Mathematics and Statistics, the University of Dodoma, Tanzania. He completed his MSc MPhil in statistics from Acharya Nagarjuna University and completed PhD in statistics in the year 2001. More than 190 research publications were published in different peer-reviewed journals in national and international, well-reputed and high-index journals. His papers have been cited more than 2,267 times with H index 24 and I-10 index 64. He is a reviewer of more than 60 esteemed international journals. He authored 2 books and 3 book chapters which are published by Elsewhere, Springer Nature and Taylor and Francis. His research interests include statistical inference, statistical process control, applied statistics, acceptance sampling plans, reliability estimation, and nutrosophic statistics. He got World Scientist recognition in AD Scientific Index 2024. He got the first rank among the faculty member at the University of Dodoma, Tanzania. He is the president of the NSIA branch of Tanzania Nutrosophic Science International Association. Professor Gadde Srinivasarao sir is widely admired for his excellent teaching methods and impressive research work over the past 3 decades. His approachable personality, positive attitude, helping nature further enhance his qualities, in addition to his inherent goodness and extensive experience in education and research.
Thank you, Sunita, for your nice introduction about Dr. G. Srinivasarao garu. Now I hand over the session to Dr. G. Srinivasarao garu. Sir, please start the session, sir.
Thank you very much, sir.
Sir, is it audible, sir? Srinivasarao, sir.
Yeah, yes. Am I audible?
Yes, sir. Yes, sir. It is audible, sir.
Okay. Thank you very much. Thank you very much, one and all, for inviting me. Principal and the management and the head of the Department of Mathematics, and a nice introduction given by the Sunita and other members. So thank you very much, one and all. Let me start my presentation. Today I want to give you some basic idea about the statistics and how to apply the R programming for some basic statistics and nonlinear optimization. Is it visible, that slides?
Yes, sir. Yes, sir. It is clearly visible, sir.
Thank you. Most of the times, this statistics is more useful in business. Nowadays, in engineering and other data sciences, the statistics is more useful. So actually, it was started in business analytics. Later on, it moved to the other fields like biostatistics, epidemiology, industrial statistics, and even in engineering as the quality reliability engineering. So statistics can be used in many fields. It is not limited to the social science, sciences, not only limited to the these sciences. So it can be used for any field. Now let us see what is the data analytics. So basically, data is the source. So therefore, collect the hidden perception of the data and then develop your report. Accomplish for business data analytics. Enrich your business data. And then, does the data analytics focus on the methods to analyze the data to increase the productivity and profitability in the business field. Main skills of the data analyst. We should have a knowledge on statistics, data cleaning, exploratory data analysis, and data visualization. Why I am considering this? Nowadays, most of the students will get job opportunities in this data analytics. If they are familiar with either R, Python, MATLAB, they are getting good employment opportunity. Because you are a faculty member, so you may encourage the students to learn these statistical packages like R, Math, even MATLAB is they are almost every student is learning in the engineering standard. So being a faculty member, you are also familiar with the MATLAB. To do your research work or student project works, you and student, if you are familiar with this, the basic statistics and the research methodology, then you can guide the students how to do the better research work in different environments. Statistics is the main aspect for researchers who wants to collect the data and analyze the data. Basically, statistics is in two aspects. One is descriptive statistics and another is inferential statistics, which makes the complete sense of the statistics. Basic statistics under the descriptive statistics, that means the basic idea is how to collect the data, how to tabularize the data, how to interpret the data by using statistical summaries like average, different averages, mean, median, mode, geometric mean, and various dispersions like range, quartile deviation, mean deviation, coefficient of variation. All these are under the descriptive statistics. Whereas in inferential statistics, we used to apply testing of test procedures. That means based on the collected information that you have collected, you can generalize the situation. Maybe using some test procedures like test for mean, test for variance, and the chi-square test, ANOVA, regression. Maybe you can make it a models, distributional models or logistic regression models, simple regression models, or if it is a time series, you can make it a time series models. Like that, different aspects you can study. If you are doing in a quality reliability, so if you are a engineer in quality control, then you can make it a control limits or statistical process control, product control, and other aspects you can apply in a engineering aspect. So a broad view of the statistics is that one is the descriptive and other is the inferential statistics. So I have explained all this. What is the even measures of dispersions like range, variation, standard deviation, coefficient of range. All these I have explained. Even testing of hypothesis. So how you use a statistician could use the testing of hypothesis to check whether the hypothesis is acceptable or rejected. Most of the times when you are doing your research project, you are making a hypothesis. And then you are doing maybe data collection or maybe some other aspects in your projects. So you are starting with some hypothesis. At the end of the day, maybe you are accepting your hypothesis or maybe you are rejecting your hypothesis. And another aspect is if you have a tons of data, before going to apply your models, you should clean the data and manipulate the data. What do you mean by cleaning of the data? The method of finding and correcting the corrupt or inaccurate records or values from the database, which we call it as data cleaning. So because you are collecting the data in a papers when you are doing a research work, and then you are entering the data in a spreadsheet, that is MS Excel, and then you want to analyze the data. While you are making from papers to the MS Excel sheet, you may do some mistakes. So therefore, you have to cross-check again, and if there is any inaccurate records or values, so you delete them and make it your database is an accurate and clean data. And next stage is you can manipulate the data. Manipulation of the data is, it should be done in a systematic manner. The method of changing the data to make it more virginalized and easy to readable is called as data manipulation. This is also known as explanatory data analysis. So therefore, before going to analyze any data, you have to clean the data and you have to manipulate the data. Manipulation means it is suitable for your data analysis. So it does not mean that you are writing some numbers. It means that you are organizing the data according to your model. Either it is a mathematical model, statistical model, or engineering model. Generally, data visuals are maybe bar charts, scattered plots, pie chart, maybe another line diagrams. Maybe you can use the area plot charts. In addition to that, in ggplot, there are number of very good diagrammatical approaches are available either in the MATLAB or software. You have a very good picture diagrams, you can draw it. And then data analysis. What do you mean? What do you do for the data analysis? Who is called as data analyst? So the person, a scientist, has to determine the organization goal. So if you are doing in a particular organization, either a software engineer or a data analyst or an institutional faculty member, your aim should be, so you have to determine the goals of your institution. And then data mining. And next step is you have to do the data clean. And another step is you have to analyze the data. Maybe using the statistical models, or maybe mathematical models, or maybe other engineering or fuzzy models. So you have to analyze the data. And after analysis of the data, you have to pinpoint the trends and pattern of the data. So what is the importance of that data? You should explain to the your organization and to the audience, so who are reading your document. And finally, prepare your report with visual appearance. So, because after completing all this, you are writing it. Maybe if you are, maybe it is a manuscript, or maybe a report, or maybe a project report. So you express all these points, and then wherever necessary, you use your visualization, then you will get a good report of your day. Now, instead of going the basic idea of how to calculate mean, median, mode, geometric mean, harmonic mean, dispersions like range, quartile. So let me go to the some little bit advanced topic in the basic statistics, naming as correlation and regression. So what is the use of this correlation and regression? So most of the data collected, there is some association between the number of variables. So that you have to identify. For this purpose, you have to study the correlation and regression in your projects. Yes. Before the correlation, you want to know the relationship. You can draw a graphical presentation that is called as a scatter diagram. A scatter diagram can use to show the relationship between the two variables. If you have a more than variables, so multi-scattered plot also you can draw it, and then based on that scatter diagram, you can find the how much the variables are associated each other. That after finding the relationship, how much they are related, what type of relationship, that can be studied by correlation analysis. So therefore, correlation analysis is used to measure the strength of association, maybe a linear relationship between the two variables. Correlation is only study the strength of the relationship between the variables. So you cannot find the no causal effect in this correlation. For example, sometimes some variables relationship is meaningless. For example, if you want to study the heights of the students and one variable, and another is the marks of the students, maybe in a particular subject. There is no, if you take a numbers, if you plot in a scatter diagram, let us say that the height is a x variable and the marks of the in a particular subject is a y variable. You can draw the diagram, and it shows the some points, and it shows the some relationship, but it is meaningless. So therefore, you should know that when you are about to study the relationships, whether the variables are meaningfully related or not. So that we have to study, that you call it as the cause and effect relationship you should know. Otherwise, simply you take the two variables and maybe either in the MS Excel or Stata or SPSS or R programming, MATLAB. If you draw a diagrams, you may get it, but the study is not a meaningful. Therefore, before constructing a scatter diagram, before calculating the correlation coefficient or regression models, you should know that whether those variables are associated or not. You have to take a suitable variables. For example, if you construct a scatter diagram, if the points are very close to each other, then you could say that a strong relationship between them. These dots are, then x is taking the some value and y is taking the some value. So therefore, if these points are very close to each other, then you can expect a strong relationship. If the points are scattered widely, you can say that the relationship is a weak relationship. Based on this direction of the thickly associated, you can also find the relationship is positive or relationship is negative, like that. And if the points are scattered like this, so they are not showing any direction, then you could say that there is no correlation. There is no association between those variables. They should show the direction, either in upward direction or downward direction, or if the change of one variable should be affected by the change of the other variable. If it is not showing any direction and they are scattered widely, then you could say that there is no relationship between the variables. And another is, most of the researchers, they are using regression models after collecting the data. So that's why I want to give some idea about the regression modeling, how to draw the simple regression modeling, how to draw the multiple regression modeling. Then I will go to the how to do it by using R programming, and then how to do the integrations, how to do the nonlinear programming models by using the R programming object. I want to explain all these points in this lecture. So this is the regression analysis. So to predict the value of the one dependent variable based on the value of at least one independent variable. So therefore, as I mentioned previous, you should know the cause and effect relationship due to the particular cause which variable is happening. That we call it as, based on that, you decide which is the dependent variable and which is the independent variable. Relationship between the variables is described by the linear function between variables x and y. Explain the impact of changes in an independent variable on the dependent variable based on this regression analysis. And here is also we can find change in y are assumed to be cause of change of the other variable x, because y is a dependent variable and x is an independent variable. In the simple linear simple linear regression model, most of the time it is based on the quantitative data. So it finds the relationship between the two quantitative variables. One variable is denoted as X and it is regarded as predictor, or you call it as explanatory variable, or you can also call it as independent. The other variable we are denoting as Y, which is called as a response variable or an outcome variable or a dependent variable. So because of the other term are used less frequently today, we'll use the predictor and the response for our study purpose. Most of the researchers, they use these two terms. One is the predictor and other is the response. Here we will study two types of regression models. One is simple regression model. That means you have one independent variable and one dependent variable. If you have more than one independent variable, then you call it as multiple regression model. So this regression modeling, first we are finding the variable relationship, and then you are analyzing how the variables are changing, and also you can use the prediction of the variables based on the one variable, how to predict, you can also apply. At the same time, you can also find the correlation coefficient between the two variables. Let us see the simple regression model. It is like y is taking the different values. Therefore, yi is equal to beta naught plus beta 1 xi plus some error term. So based on this error term, by using the method of least squares, we can estimate the parameters of beta naught and beta 1. So by minimizing the sum of the squares of the errors, we can estimate the parameters beta naught and beta 1. Let us say that you used the technique and you have estimated the parameters. After substituting those estimated parameters, we call this as the fitted model. That means y hat is equal to beta hat plus beta 1 x. Beta naught hat is the estimate of beta naught, and beta 1 hat is the estimate of beta 1. So this beta naught hat and beta 1 hat are obtained by using this minimization of sum of the squares of residuals. So you can assess these estimates. What is beta naught? Beta naught is the average value of y when the value of x is 0. What is this beta 1? Beta 1 is the measures the change in the average value of y as a result of 1 unit change in x. In social science, they call it as beta naught is the intercept and beta 1 is called as slope. Let me apply R programming for this simple regression. Later on, I will also introduce the multiple regression and numerical integrations and other even optimization techniques, and like in operation research, objective-oriented, nonlinear programming problems. So I'm not going in depth because even though it is a faculty development program, we are not sitting physically, so we are not applying the computer lab. Therefore, let me skip this essence of these points, how this R programming can be used in different fields, different applications. Maybe you can give some idea to your students where they get the good job opportunities if they learn the R program. So nowadays in worldwide, these industries, they are using R statistical analysts. The statistical analysts who are familiar with the R. Even worldwide, more data analysts are using R because it is one user friendly. Also, it is free software, no need of registration. Whereas if you see the MATLAB or Python, you should register. So therefore, you have to pay some amount to the software providers. Whereas R is a free software. Anyone can develop any modules and can upload in the R software windows. So nowadays, most of the familiar companies, famous companies, they are using the R data analysis. So like Thomas Cook, Facebook, Bing, Texas, Wipro, so Google, all these they are using statistical analysis. So these are some statistical advantages of this programming. Let me skip this because we are not using computers in a way. Previous, when I was a research scholar, we used to use the Fortran language. So instead of Fortran language, C language, the more advanced languages are, and it is simple and easy to apply in any field, not only statistics, physics, chemistry, engineering, any field. You have thousands of modules are available in R. So therefore, you can use them and you can develop your coding for any research purpose. My concentration is on basic statistics models. So that is how you model this data. Let me take instead of the data PL 2001 data, let me take this math cost data that is available in the R software. So if you take this data, how you are retrieving the data? I am giving the simple coding. Please bear me. Without software, I am explaining this. Maybe it is boring. So data can be retrieved by using the syntax data empty cars. So if you want to see how many variables are there, what are their headings, you can type simply head cars, add empty cars. You can know that what are the variables are available in that software, in the data set. Similarly, what types of variables are there in that data set, you can find by using the str. If you want to find the correlation coefficient between them, you can type simply COR. COR calculate the correlation coefficient between the different variables. So if you want to plot the scatter plot between the different variables, you use this simple code plot empty cars. It plots all the variables. Let me take this on. One minute. Is it visible? Hello, anyone?
Yeah, it is visible.
Okay. So, as I mentioned previous, scatter plot is a single plot in between the two variables. Whereas if you have a large data set, so if you want to find the relationship between the variables, at a time, you can draw the number of multiple scatter plots, and then you could identify that what is the relationship between the different variables. This is another advantage of this previous plot and p-cars. In this, all variables relationship it has given. So now, if you want to calculate the simple regression model, so if you apply the calculator or if you use the MS Excel, it takes a longer time. Whereas if you use this regression modeling syntax, LM, using that LM, you can find a regression modeling for the different variables. For example, you want to find a relationship between the fuel and miles. For example, if you take this type of data, you can find a linear relationship between the variables by using this simple syntax. So now you are giving the first variable, that is the dependent variable, upon symbol, and independent variable. And then you are giving your data name, whatever the data, MP cars or PL data or some other data. So therefore, your syntax is here LM, and the first is the dependent variable, and the second is the independent variable. Then it could calculate the data, and then you can also plot the data. This, let us say that the regression model is S11, so there's that S11 plot it will give. And if you type the summary of S11, it displays the results. Let me apply for the MP cars. You are retrieving the MP cars, as I mentioned previous syntax, and then I have shown the scatter plots. If you want a particular scatter plot between the two variables, that is that one is the weight and another is the MPG. If you want to find the only relationship between these two, you can write the syntax plot empty cars dollar symbol weight WT, and empty cars is the data name, then dollar symbol, and another variable name is MPG. And then if you want any other headings like that the scatter plot heading is weight versus MPG, and what you are taking on x-axis, what you are taking on y-axis, how much uh, accurately the plots, the characteristics you can give is maybe some number, numerical number. Then it plots the only simple scatter plot between the weight and MPs. Now, if you want to find the relationship between these two, that is the regression modeling. How you find the regression modeling? So you can use this expression. The plot is the one. Previous you have mentioned each variable, and now you are mentioning WT upon MPG. It displays like this. So you have given weight versus MPG, MPG on y-axis, weight on x-axis. So it is a regression line. It is a decreasing regression line. So you could find the how much association between the variables. So you can do the model evaluation also, whether that model is accurate or not. If you want to study, then you may calculate by using the syntax summary function. And in this, you will get the R score value. You know that R square value, if it is near to the 1, then your model is more accurate. So therefore, you have to look for how much is my R square value or adjusted R square values. Similarly, what is the significance of whether the each coefficient beta naught, beta 1 are significant or not? So we are applying the testing of hypothesis whether beta naught is equal to 0 or not. Beta 1 is 0 or not. We are applying the testing of hypothesis. So therefore, for each regression coefficient significance, we use the t-test, and based on the t-test p-value, you could identify that whether each coefficient is significant or not. Another type of model evaluation is residual standard error. So you are finding the residual standard error based on the smaller residual standard error. If your residual standard error is a smaller quantity, then your model is a value. So in the regression model, if you want to display the straight line, that you can use the syntax as AB line. AB line, your model, and then what color you want to fill your colors. If you want to find only coefficient, you can say that COEF and mod SLR, whatever the model you have already developed. So in that, it displays that how much is the intercept value, what is the weight value. So that means it is like y is equal to, so your y value is, what is that? Your y value is MPG. So MPG is equal to 37.28512 minus 5.34472 times weight. So that is the regression mode. If you want to find the confidence, that is the confidence limits of the each regression coefficient. So your syntax is confin CONF INT. Here is the confidence intervals of that model. Whatever the model you have given, that model name you can give it. It displays the most of the, by default, it shows the 95% confidence limits. So intercept confidence limits is this, and weight confidence limits is this. Similarly, if you want to express them in another way of expressions. You can also write C bind, R bind, like that, different expressions you can give your confidence limits. And another importance of this regression modeling is predicting the values. So what is the predicted value with the some uh, independent value? So for example, let us try for what is the MPG value when the weight is 1.25, 2.13, 3.45. So if you want to do it, you can do the syntax, predict, and then your model. Now you are giving your new data set of frame is the data frame. You are giving new weight data is 1.25, 2.13, 3.45. Then it gives your predicted value of first predicted value is this, second predicted value is 25 point something, and third predicted value is 18. So main aim of this regression modeling is one is modeling of your data, second is predicting of the data. Meanwhile, you are also testing your hypothesis. Let me extend this model. For example, if you want the R score value, so you can say that summary of your model, dollar symbol, R score. So your R score value is 0.75. Therefore, it is nearer to the 1. So if it is approaching to the 1, then you say that your model is a valued. Similarly, if you want to find the standard error of the sigma, then you say that summary of the model and dollar symbol with the sigma, you will get the standard error of the your standard error of the sigma. And another model is multiple regression model. So previous we have modeled the two variables. One is the dependent and another is independent variable. So if you have more independent variables, that means more than one independent variables. Let us say that x1, x2, and so on, xk are the independent variable, and y is the dependent variable. If you want to model it, the model structure is like this, and beta 1, beta naught, beta 1, and so on, beta k are the regression coefficients. So these coefficients can be estimated by using the ordinary least square method by minimizing the sum of the squares of the errors. So let us say that after estimating the parameters, you could find the uh, uh, estimated value of beta naught, beta 1 as like this, and the fitted model is like this model. Here we used to test the hypothesis beta naught, beta 1, and so on, beta k is equal to 0. Alternative hypothesis is they are not equal to 0. And another, whether the model is also valid model or not, you can use the F statistic. So F statistic formula is like this. So let us do it by using scattered plot. By using R programming. As I mentioned previous, you can find the correlation coefficient between them by using this formula. And these are the different ways of visualization. So how to find the correlation plots? If you want circle format, elliptical format, different colors, different numbering, etc., you can do it by using the correlation plot. Also, you can find upper sided lower sided, like the different structures you can find by using the R program. Now you can model your uh, data between the different variables. Now, previous we have modeled between these two variables. Now, weight is the independent variable, cylinder type, displacement, and HP, DRT, all these are the independent variables, and MPC is the dependent variable. Then how to model it? So we are using the multiple regression model. So here is also we are using only syntax LM. Previous we used MPC upon weight. Now, if you want multiple variables means in between the independent variables, just you are writing the plus symbol. Weight plus cylinder, CYL plus DASP plus HP plus DR. Then, if you want the summary of this model, so what we have given the name? Model MR, multiple regression. If you want its a summary, you are typing summary model MR. If you want ANOVA, you can also find from this model. So, other way of expressing this multiple regression modeling is just you are not mentioning all the variables. So rest of all variables are independent variables. Then you can model like this also. LM, MPC upon symbol dot comma, you can give the data type. Then it gives the your model. If you give this big formula, big expression, or if you give this simple expression, you will get the same results. The output of this result is it is from the first formula, LM. You have given this formula. It shows the residuals because residual means your model minus your estimated values. That means y minus y hat values, we call it as the residuals. So those residuals, what is the minimum value of the residual, first quartile, median, third quartile, and maximum value, it is showing, and also coefficients. So first is intercept, that is the constant, and what is the coefficient of CYL, DASP coefficient, HP coefficient, dot coefficient. Then another is standard error. Then third column is T value, and then last column is the P value. So while drawing the conclusion, different model. Also, non-linear, it is up to simple regression, multiple regression, all these are the linear models. If you have a non-linear model, those by taking logarithms on both sides or some other manipulation, you can convert them into the linear models and then you can use the LM function. And another aspect of study which is purely related to the mathematics is calculation of the integral. So let us say that you have some integration of a function. So how you are writing the integration of the function? So integrate, you are writing some function, let us say that f, you are giving its lower limit and you are giving its upper limit. If you want how many sub intervals you want to divide, that also you can give it, and this is the syntax of the integral. Let us say that we have a function. You want to find the integration 0 to infinity. Your function is 1 by square root of x plus 1. Integration 0 to infinity, 1 by square root of x plus 1. Sorry, 1 by x plus 1 times square root of x. This you cannot solve by using your integration by substitution or some other UV rule or coefficient rule. So in that case, we are approaching the numerical integration. So you have a Gauss formula and the Gauss quadrature formulas and the trapezoidal coefficients here. Other rules are there. Therefore, here we are using the one of those models. So it calculates automatically this integration. So how I am writing this function inside of the function, let me call it as integrand. How I am writing this function, function of x. How I am writing this 1 over x plus 1 times square root of x. This is my function, inside function. If I want to evaluate that integration, you can give the syntax is integrate this function name, integrand. Your lower limit is 0, your upper limit is IAM. Then you could get the answer for this integration. For example, if you want more than one variable, so because we are using the double integrals, triple integrals, like that, multiple integrals if you want to calculate. In that case, you want a package, the name is cubature. Use that cubature syntax, that package. First, you load that package. I'm not going in depth of this calculations because you are not maintaining the computer, laptops. So how you are writing this multiple function, say called f, function of x, you are giving the suffixes. So your function is 2 by 3 times x1 plus x2 plus x3. That is your function. You want to integrate over, this is the triple integral. Triple integration 0 to 0.5, 0 to 0.5, 0 to 0.5. Your function is 2 by 3 times x1 plus x2 plus x3. Of course, it can be solved by using ordinary integration also. Let us try that by using integration by R package. So you are writing the function in this manner. So now, previous is integrate. Now adopt integrate. If you have a more than one variable, you call it as adopt integrate in cubature. Then you give your function, recall your function, give the lower limit. Lower limit is a vector, 3 values, 0, 1, 0, 0, 0. And upper limit is a vector C of 0.5, 0.5. Then it gives the value 0.0625, and its error. Error is a true value minus this integration by using the numerical integration. You can also evaluate exact answer, and also you can evaluate this by the numerical integration technique. How much is the error? So it is very, very, very small. So therefore, your integration value is this amount. So like that, numerical integrations, you can also do it either single variables or multiple integrals. You can evaluate by using R. This is the one application. And another type of problem is also given. This for exercise. And now, in operation research, we have a optimization. So you have not given you have an objective function and the constraints are not given. Unconstrained objective function. Let us say that your function is 4 times of x1 minus 1 whole square plus 7 times of x2 minus 3 whole square plus 30. That is the function. You want to evaluate, you want to find the optimum solution. This is a non-linear programming problem. In operation research, we used to find this type of solutions by using Lagrangian principle, Cohen-Tucker conditions by using if you have a constraints. So if you don't have the constraints, so it has to apply the golden technique. So therefore, let us try to find this optimization by using R program. So now you are writing this as a function. F is equal to function of x. How you are writing your function? 4 times of x minus 1 square plus 7 times of x2 minus 3 square plus that. That is your function. You want to find its roots. You have 2 variables. Therefore, you are giving simply, you are using the package in R called as optimization. You know that optimization means either minimum or maximum. But this optim package will provide only minimum solutions. If you want a maximum solution, you have to give negative of the function. You know, in the operation research, how you are giving. So how you are converting the maximization simplex problem into minimization problem. Same technique you can apply here. Here in software, optim means it gives only minimum solution. So you are giving initial solution and your function. So then it evaluates the experiment. Similarly, if you have another function, x1 squared times x2 plus x2 cube times x1 minus x1 x2 times. So if you have a function this, you can also find it like this, root of optimum. You are giving some two initial values and your function. You can find them. One is the numerical integration, another is nonlinear programming problems without constraints. Even with constraints also you can evaluate the function. But sometimes you have only one variable. In that case, instead of optim, you call it as optimize. Optimize, then value. So you can write optimize and then you can solve them. And another nonlinear programming applications in statistics or in some other areas. You have a large function and then how to evaluate those functions. Those are not in a linear form. So, and you have a number of parameters. So, in that case, you cannot solve those functions easily. You have to apply nonlinear programming problem techniques. Let us say that in statistics we have a V-Bull distribution. The distribution nature is like this. F of x, alpha comma beta are the parameters, and this formula is like this. Now we want to estimate these parameters. This is a nonlinear function. If you want to estimate these parameters, you can use the different methods of estimation. One best method is maximum likelihood estimation. Let us try that. Maximum likelihood estimation means you are finding the likelihood function. Likelihood function means product giant probability density function of the variables x1, x2, and so on, xn. And then you are taking the logarithm on both sides. Then you are claiming log likelihood function. Again, that log likelihood function is in terms of logarithms, and also it is a large expressions in nonlinear form. To evaluate that, we have a maximum likelihood estimation procedure. In that procedure, the likelihood function L should be maximum. Likelihood function L is product of these probabilities. L must be maximum. So to find either maximum or minimum in our programming, we can use the optim. This optim package gives only minimum solution, whereas you need maximum of the likelihood function. So first you write the likelihood function coding. So code is, you can write like this manner. N is the number of variables. Your beta is parameter 1. Alpha is parameter 2. And if you take logarithm on both sides, you want to find the maximum solution, but optim will give the minimum solution. Therefore, multiply with the minus sign to your log likelihood function. So therefore, you multiply with the minus sign to the function, and your expression is like this way. And this all together is the minus log likelihood function. That means if you find the solution for minus log likelihood, you are getting the maximum of the likelihood there. So how to find this? First you write function like in the previous integration. Now you want to find the solution for this. How to do it? You are approaching the optim package. You have to give some initial values. Then your function is log likelihood function, and your data name is variable x. And if you want a Hessian matrix, you know that the Hessian matrix is the second derivatives of the function. So second derivatives and its function values, if you want, you say true. If you don't want, you say false. And after that, you want to find the data estimated value. You call it as data hat. From this out, then your parametric value, dollar symbol parameter. Lambda value is your second parameter. Therefore, out WD dollar symbol parameter. So I'm not applying this estimation procedure here, but those who are interested, you can adopt this coding to find the maximum likelihood estimators of the parameters. If you don't want to use the logarithms of the function and you have a variable distribution function already, then you can also use other way. Other way is you have variable distribution probability density function. You have already probability density function. You write the code for this probability density function. Then you can write directly this coding. This is called as D variable means probability density function of the variable distribution. How it is? Variable x, first parameter, and the second parameter. Usually software is in terms of rate. So share parameter means 1 by rate. So therefore, that's why you are writing 1 by theta R2. And then this is the R value. You want to find the negative values. Therefore, minus some logarithm of the R. You calculate it. So it is the sum of the product of the logarithm of the values. That is nothing but the minus log likelihood function. You calculate that. This is the other way of calculation. Then you use the same technique, you will get the answers. After getting the answers, whether that model is a fitted or not, whether that variable distribution is fitted to this data or not, X data, I have a X data, whether my variable distribution is fitted to that or not, I can use the Kolmogorov-Simrose test that is called as KS test. How to apply? KS test, variable name, and you are giving here cumulative distribution function within the course. Then whatever your estimated values of the parameters that you give it, then it displays the p-value and a p-value. You know that if p-value is more than 0.05, hypothesis is accepted. You are writing as null hypothesis is the data is not fitted to the variable distribution. Alternative hypothesis, you are saying that hypothesis is, null hypothesis you are writing as the data is fitted to the variable distribution. Alternative hypothesis you are writing as data is not fitted to the variable distribution. So once the p-value is greater than 0.05, you are accepting it. That means your data is fitted to the variable distribution. That means you are saying that you are estimating these parameters, one aspect. It is a non-linear function. You are estimating the parameters, and then whether my estimation is correct or not, whether my estimation is valued or not, you are applying the goodness of fit test. So you are applying the KS test, Kolmogorov-Simrose test, and then you are seeing that whether your p-value is greater than 0.05 or not. So if it is greater than 0.05, you are accepting that. Just being a statistician, I have explained for variable distribution. Therefore, if you are doing some research work, even this type of package is available in R programming and also Python programming language. So therefore, nowadays, all researchers are using, most of the researchers are using these three types of packages, R, MATLAB, and Python. Among these, R is user-friendly and freely available. Other two, you have to purchase the softwares. So therefore, so in conclusion, I conclude that our package is more suitable for non-linear programming problems that we have studied up to now. You can also apply in your field to obtain the non-linear programming problems. So thank you, Anana, for patient listening. So if you have any questions,
Thank you, sir, for your lecture on basic statistics and nonlinear optimization using R. This is the time for question and answer session. Because of huge participants, any participants who is interested to clarify their doubts, please come forward to post in the Q&A box. Sir will clarify the same. All the participants, dear participants, please post your questions or inquiries in Q&A box and sir will answer the same. Dear participants, sir, చూస్తాను సరే
Sir, namaste, sir. Srinivas, sir.
sir.
Sir, thank you, sir.
whatever you post it is, sir.
So it is a truly useful and wonderful lecture, sir.
Okay, thank you, sir. Thank you, sir.
No doubt the session is highly enriching and enhancing our understanding and demonstrating how these concepts strengthen and model performance, sir. Really wonderful lecture, sir. Thank you very much, sir.
Sir, thank you.
Thank you, sir. Thank you for inviting me for your faculty development program.
Thank you, Ananda, for your good response and valuable support. Expecting the same cooperation for the remaining sessions also. Today's session with the vote of thanks by co-convener Dr. T. Srinivas Rao Garu.
Good evening to all the participants. On behalf of the Department of Mathematics and the participants, I would like to express my heartfelt thanks to our today's resource person, Dr. G. Srinivas Rao sir, for his valuable presentation. In today's presentation, Dr. Srinivas Rao sir has discussed about basics of R software, its merits and demerits, various operations, etc. Also, sir has given an introduction to descriptive statistics, various probability distributions in R, hypothesis testing, optimization for nonlinear functions, etc. Today's session is really enriched with the presentation given by the resource person, Dr. G. Srinivas Rao sir, on basic statistics and nonlinear optimization using R for exploring the knowledge in teaching community. This session is very useful to the faculty members for strengthening their skills in statistics with the R package. Finally, you are all requested to fill the feedback form before 7 p.m. today. So we are sharing the feedback links both in the WhatsApp group and YouTube channel. Thank you very much.
Thank you, sir. Thank you, sir, for inviting me.
Sir, thank you, Srinivas Garu.
Thank you. Thank you, Srinivas Garu, and the head of the department and Karnakaran Garu. So thank you very much. Ananda. Okay.
Thank you, sir.
Shall I log out?
Sir, expecting the same cooperation in future also, sir.
Sure, sir. Sure.
Thank you, sir. Thank you very much, sir.
Kader also telling you about you are organizing more activities.
Yes, sir. He is the backbone of our department, sir.
Okay, okay, sir. Okay. See you, sir. See you.
Okay, thank you.
Leave it here, sir.
And చేసేయండి మాస్టర్.